size is a dope who meet this sort you. We really appreciate Anastasiia, stage is yours.
Okay, this number is okay, okay. So, hello everyone, my name is Anastasia. I came from Berlin, originally from Ukraine. I lived in Germany already, I don't know, 8 years or something. And I work as an associate director of engineering and creative instruments in the DJ department. I'm not a DJ myself, but I really enjoy the work and also working with the DJs, developers, and DJs at the same time. And in my free time, I speak at the conferences and I also organize a Python meetup for quite a while. And I have different experience in different domains, and I really like sharing what I learned through the years. And I really like a community because some days I speak with Python for such about time, although I manage people, but I still enjoy learning and helping people to learn from me and from others. So today is not about me, it's about code, production code. First of all, anyone has a clue what the production code means to you? So anyone wants to speak out? What is the production code for you?
Reliable scores, bug-free.
Okay, yeah, is it everything? Okay, so the difference between the production and non-production code is that it's light and you cannot change it on the go. It's not on your machine, it's somewhere else. And I really like this part of the book that I saw it recently release it. I'm gonna cite it. We worked so hard. We work hard with the project. It looks like all the features are actually complete and mostly you can test. We can read exactly where done, you're done, or are you? It really shows that it's not pretty clear whether you're done or not. When your code is done, you have the tests, but are you actually done? Are you actually ready for production? And tonight I will share a couple of checks with you before you go to production. Or if you're already in production, we can already stop somewhere. First of all, code quality and readability. If we're talking about before production code, of course, it's nice to add editors and formatters. It's easier for the coder to, and probably you already know and use them. And it's always nice to add annotation. And I really like adding the top speeds to the code that I write. Why? Because the code is still leftable, and then it takes some time to recover the knowledge that you had before. Even in the maths, you might not recall what you were thinking about while writing that or the other specific question. So you can add a few checks to your CI pipelines, like making dependencies frequently to remind you that, oh, there is a new package, you got to try it out and update it. Also, linsers and formatters. This is how my CI for this test project will look. I set it up on the GitHub Actions. And as I promised, you can check the entire code. I'm going to share the link in the site. So there are lots of edits on the CI, we can catch them. But actually, there are lots of things you can add extra to the CI. You can check in here the code for this stuff, because I'm not going to share within the script the entire code. Okay, so what else can we automate and improve in our CI? Except for the ones that I mentioned before, you can add a quotation, either your continuous integration. So then every time when you add some piece of code, it will remind you, oh, you forgot to add those streets. It's great, there is a tool for it, and I use it quite frequently. It doesn't force you to update your documentation like Greenie or some extra examples or the other document, but it will force you to at least add the top screen and display the monies that you're writing. And it works. The other check is to check how you handle exceptions, whether you handle exceptions or not. Because when you start with production and then if you don't handle exceptions, it's bad, you already know it. But if you do handle exceptions and then, for example, we skip them or if you learn them or, I don't know, you write someday, usually in your computer, you can run it again, you could check it again, but with the user, if there is a user, you cannot do it again. You need to make sure that you have all the information needed for the exception, why it happens, where it happens, and then handle the exception properly. So you can use try except, but the only catch here is that you should not catch the base exception, because then you will catch all the exceptions over there, the keyboard interrupt as well, which is a TQA, so it might be able to create the program with the keyword, and you need to log the errors. So we are slowly going to the next step, which is mocking. And I really like this picture from the 12-factor app. It was, this methodology was very popular some time ago, and it was all over the place, all the other app, let's check it out. It's for building a software as a service applications. And it's good when you treat the logs as event streams. So you have this future event with only information inside, and you can parse the information, and then you can see what exactly happening in that specific event. So what are the main attributes of the logging? When then happens, so the timestamp is usually always out of the box with the logging, then where it actually happened. That's a bit tricky. You can add a trace ID, for example, to see where it came from, and if there's a trace ID, it will propagate from one function to the other, from one body to the other, and then you will see the whole path, where it started and how it was going through the time. Then what actually happened, what was bugged, and then who was the one caused the bug. So when something happens in production, and then you don't need to get a tactic to go deeper and then find the good cause. You already have everything. You just need to filter by the ID of the issue and then see the path of that issue. So if you would set up the logging in Python, there would be always a logger inside. You can pick one, and you would use the handler, and then you would write the logs somewhere. Don't forget to write the logs into a proper place and then rotate them so you would not fill the entire file with gigabytes information. And if you have, for example, some text that to handle the logs, then I would suggest you to do something like this. I'm sure it's too small. I think you can see something. So the top super tag example has two examples in it. The colorful one and another one. The colorful one has the key value pair. It's a spark log. In there, both colors will not see on the production course, but in general, you can filter by all the keys, and I see what actually happened with the entire cooker. And if you have the usual stepper clogger, you have the whole message, you can subtract their HTML pairs, but then it's so much harder to guess what actually happens and then to process that information instead of just having the key value pairs and then to have the text in there. So what our DevOps did for the logger, we just used the struct topics first, we used standard logger. So it was tracking everything. They were tracking the ID of the events, also the container ID, the user ID, everything on the top. And then there was the entire message. So the problem is that you would parse the message in a specific way. So they were writing a lot of functions to parse a specific message. Here it's already out of the box. It's already sort of parsed, and then you would put it into specific structure. And you can process them in a very specific way. So the second example on bottom, and that's a specific processor. It would hide password, for example, if you want to write HIMA price, a sensitive information, I'll talk about later. that you can make sure that that information is fit. Then you can also add the timestamp, and you don't need to write it in a specific. And can find all the examples in the compilation key form. So let's go to security. There are a lot of things you can check before you go to production from the security point of view, which is input validation, checking sensitive information, checking your Docker images, checking the tools that you use. Mainly there is something for security specifically to check. And of course, there's secure authentication and authorization. So let's go to first one. Input validation. Obviously, it's very concordant, so the attacker would not be able to add something extra spicy into your input. You need to first define the input holidays when they intercept the basic criteria, and then handle the invalid input. For example, if there's some executable inside, or there is some code that you don't want to execute, you just need to get an input, the proper one. This would save your life. And then we need to secure the default values. If the value is not there, so it will not get frozen, and then you will not see codes on the screen. And you have to take this the next level with the regular updates of the info correlation. Sensitive information. This is very important. We are in Europe, and we have the GDPR compliance, so we have to be compliant with the sensitive information. That's every information bit about the user, their password, their name, their address, so everything that can identify the person. And please do not log or write to the screen or to the file the entire values of the objects. So if you do that, the entire object, you don't even know what's inside of the object. Another developer can update that object and then add some extra information about the user, and you see it on the next steps. And then if you log the entire object, you cannot check whether that information is even or not. So please avoid the hard-coded values and the mesh towers, and then store and isolate securely that you can access the data, delete the data, obtain the data, and whenever it's bit, check it. Next one, Docker images. There is a lot to say about Docker images. You can also check the Docker file in my example. First of all, if you use Docker, you need to trust the source or you take the image. This is very important. And there is a link for the byte official Docker images, and there is a huge list of ways. So you can use one of them. There are different ones with different size and different features. So some of them are faster, some of them are slower. But for sure, make sure that you know the source where the image picked from. Then you need to save the images just in case if you are not updating your code, and this can happen. This already happened in my previous company. We used to save all the Docker images in our registry on our machines. That in case they are not there anymore, and download them, they are for example so old, and the code was not updated for like 10, 15 years, somebody forgot, but then it's still working. It would be still working, and you would be still able to get those images if you need to really well update. If you don't save them, then, well, there is no chance you will need to update, and it can take a lot of fun as well. So the best practices on Docker files is to use copy instead of add, because you just need to copy the files. Well, sometimes you need to add, to use the add command. It provides just the following advantages, which is handling the URLs and also exporting the archives. Most of the time, we just need to copy the fold from one place to another and just put it into the image. And so every time you use the run 40 and pad to create the next layer, and then it would roll your image across screen. If you wanna make your images a bit slower, I would suggest to combine them all together with the and. So you can actually run them in one command. It will not create more on layers. And that first use CNT instead of exec. There is a very simple reason that it doesn't use that the shell just directly goes and executes the code that you write in the CMD command, which is way safer. And you can also link the Docker files. You can check whether the Docker file is bootable. And so the same kind of leader as Python. And then the other thing is not to use the root user. So if you write the entire image under the root user, then it would be a bit of a breach of security. So the adapter would get access to the boot, then they will have the access to the entire image, to everything, to the code, to everything good is there. If you use a specific user, that will be much harder. Then if you use if they even get the access to the root user, they would not be able to get anything because everything is running under a specific user. And of course, using the multi-stage builds, what you need a smaller image, you can pre-build the entire installation part, and then you can just copy it to the final image, and also you can combine different layers all together. So, example. This was the first example of the Docker image. I just took the byte build, and then I created the super tiny fast API application, which just has the main. After that, I try to use the linter. So as I mentioned before, don't use the add command. And then if you accidentally use the add command, Meter will complain and it will say you, oh, you used the add, can you please change it to the code. So it's very useful. It's super tiny and it's really nice to use this later on the CI. So whenever there is a problem, you can actually spot it by direct way. The only thing, the caveat with the data file, if you use the multi-stage builds and then need to update something, it will complain of it, but you need to also ignore some of the things, the pre-built stage. So here's the example. This was my second example of the Docker image with the multi-stage build. So the first part is the part where you actually install dependencies into the virtual environment. I did prefer the virtual environment because it's very easy to just pop it from the pre-built image to the final image, and then you have memory in there. Although there are different ways to set up the multi-stage builds. So the first part, I also put a ignore for the liter, how to read, that's the Docker liter that I use. So I put the ignore just because it complains to pin the dependencies every time you update something. And in case if you pre-build the image, compile all the things, and then you just throw it away, the tip, but you don't need it anymore, so you don't really care what is happening there. And then we just copy the environment that we created, install the application, X, did right. Super easy. And another one about the root user, this is how to use a custom user for Docker files which you want to build. Another thing is which image to use. There are lots of the images. If you go to the official Docker images for Python, it's really huge list, not just in versions, but also there's the standard one, there's the Alpine, there's Sleep. So all that they come with the pre-install Python. You can also get a basic image and boot also the else, and then install Python either manually, but even arranging the existing one with the specific version of the byte reinstall. Some of the versions that Alpine, for example, that's the one that I did before, but actually it makes everything slower. So you can use the Steam version or the standard version. It is a bit bigger. The Steam version is small, pretty similar to the Alpine. I think you take the Alpine to do just test for and everything. And the next advice on the security, the tools which you can use. I use the tool which is called Sneak. That's a tool which would analyze your entire code, Python code, and even the images that we use. So remotely, whenever you have every PR, it will suggest you how this dependency would cause you the problem, or that image will cause you the problem. It will just analyze the code and then give you the feedback. It's also free for open source, and there are also very spotted commercial for that. This is how it looks. It will tell you the Docker file, and in my case, if you use different base images, tell you those are the vulnerabilities. This is how to fix them. You can open the PR from there. Although I don't recommend to use that PR directly, sometimes it creates just a noise. It's so much easier to just upgrade one dependency instead of rating every dependency one by one. So this is the code that I mentioned. There is a Docker file in there. There are also examples of their exception handling and also logging. And this is the list of Python official images. You can see there are no dots at them. Unofficial Docker Hub. You can also compare them in there. And this is how the security tool, scary tool goes by. You would see the project, you can import them directly from GitHub, for example, and then you will see the vulnerabilities from here. You can fix the VR or the PR to fix, and then you can see more details, which package which was installed specifically in that system that you use in the Docker would cause a problem. This is how the ties is at. Oh, I lost my course. Anyways, thank you. This is it. I hope you will enjoy building your images and then updating your production frame.
Cool. Yay. Questions. You can.
How did you try to upload the pixel text for building images instead of the Docker?
No, I didn't remember this.
More questions. All right. Can you catch it? This is a eating. Just kidding.
You can't talk very silo. Thanks for the talk. I wonder whether you have some practical rescue tools to hide sensitive information from walks, for example. Maybe use this up by the post-processing or maybe not first as that.
Yeah, you can also check the code snippets. There is one small code snippet for the sensor correction. It would hide the entire input. This is all about the processor, basically. You can add multiple processors in there, and then it would process the entire long message, and then would give you the hints where it's needed. So basically, it's up to you to write the entire function how to process it. You gotta write also the cuts.
We have time for one more, very last part.
So what kind of production how do DJs need?
Oh, that's a spicy question. Well, we have a C++ in there, and we use Python for testing, actually. We use ROP framework, and we have a specific written Python budget about the entire model to test the application, but the entire application is always plus.
Cool. We hold another big applause to Anastasiia. Very good.